So this chart that has been at the top of our notes for the past couple days will be at the top of your test as well. The first group of questions asked us to find the distance between the 2 points and then also to find the midpoint between the points. On this assignment, there were several students that forgot to do one of those things, and every year on the test there are some students that don't read their directions careful enough and forget to do one of those things. I put them in bold, so hopefully that will help you remember that you need to do both of those things. When we learned about distance, we learned a formula, or we had a formula in our notes, that some people chose to use to find distance. If you should choose to use this formula, that is absolutely fine, but notice that it is not on the review, which means it will not be on the test. So the other way we thought about distance, for those of us who are not good at memorizing formulas, which is me, and maybe some of you as well, is that we plotted our 2 points, 0, 0, and 4, 4. And when we say that we want the distance between those points, that would be the length of that segment that connects them. So I'm going to connect those together. To find the length of that segment, we made a triangle, a right triangle. The sides of that triangle in this problem both have length 4. We can count out between the points it's over 4 and up 4. And then we can apply our Pythagorean theorem. 4 squared plus 4 squared would be the distance squared. So that's 16 plus 16, which is 32. And we'll take a square root. No decimals. We want exact answers only, but simplified when possible. So to simplify the square root of 32, what is a perfect square that divides into there? 16. So we can break this down to 16 times 2, which is then 4 times the square root of 2 for that distance. You didn't really have to go through all these calculations if you draw it out and notice that this triangle happens to be a 45, 45, 90 triangle, and you remember some stuff from when we studied trig a little while back, which wouldn't be a bad thing given that that exam is moving ever so close, and there will be trig on that exam. So if you happen to notice this is 45, 45, 90, that saves you a lot in calculations. The second part asks us to find the midpoint. The midpoint is the middle or the average of the 2 points. So we're going to average the x values, add them up, divide by 2, and average the y values, add them up, divide by 2. So that gives us the 0.22, which should be right in the middle of that segment. Okay, midpoint is the average of the x's and average of the y's. So we add them up, divide by 2. Questions? Go ahead and work on the next 3 of these, all of the same type while I take care of some paperwork stuff. But on number 3, please change that -1 to a +1. The calculations are a lot nicer then. So on number 2, if we plot our points, we actually end up getting exactly the same triangle as we had in the first question. It's just flipped over. But all the lengths are the same, which means that that other length should be the same as well, meaning we really don't need to do any more calculations here. If you do, that's fine, but if you notice that it's the same triangle as in number 1, we can just flip over that length. It does change the midpoint, however, because the midpoint now needs to be between those 2 points, which is the average of the x's and the average of the y's. So that midpoint is now at 2, -2. For number 3, we plot those points over 8 up 24 and over 1 up 0. Connect, I get a triangle that has a side of 24, a triangle that has a side of 7, and so we can do Pythagorean theorem. 24 squared plus 7 squared equals distance squared. And plug that in the calculator, which gives 625. And take the square root of that, and that's 25. For midpoint, we average the x's, so 8 plus 1 divided by 2, and average the y's. 24 plus 0 over 2 is 4.5, 12, or 4.5, or 9 over 2. I don't care how you leave that first part. Okay, fractions or decimals are okay. And for the final one, plot over 5 and up 4, and back 5 and down 4. And connect. Gives us a horizontal length of 10 and a vertical length of 8. Counting out between those points. 10 squared plus 8 squared equals distance squared. So that gives 164. What's a perfect square root that goes into 164? 4 divides into 164, so that gives 2 square roots of 41. So simplify square roots when possible, but no decimals. We average the x's, 5 plus negative 5 over 2, and average the y's, 4 plus negative 4 over 2. We get 0, 0. So the origin is exactly in the middle of those points.
Why couldn't we do like two smaller triangles to get the distance? You know, like this, and then just add them up.
You could do that. So you could make it into two separate triangles and say I have a triangle here that's 5 and 4, and a triangle here that's 5 and 4. For each of those, you should get a square root of 41. So adding that up would give you 2 square roots of 41. You should get the same thing either way.
Okay, because I got square root of 82, and then the 5.
Square root of 82, or add that up, would give square root of 164, which is the same thing. Questions with writing an equation, you will have that chart that's at the top, so you can refer to that chart. I always like to plot what I'm given just so that I can see what's happening. It often helps me make the decision between the horizontal and the vertical form of the equation. So for number 5, I have a parabola, vertex at 0, 0, focus at negative 2, 0, and our parabola is supposed to open up around our focus. So by plotting that, I can see that this one is a horizontal parabola. And from the chart at the top then, choose the y minus k equals 4p x minus h, the horizontal parabola equation in the chart. Our final answer should have x and y as the only letters, and everything else should be numbers. So first, what's HK? The vertex for a parabola. So in this problem, H and K are both 0. For a parabola, HK is the vertex. P is the distance from the vertex to the focus, and it's directional. So in this question, P is negative 2. Since it's left facing, left is a negative direction. So P is negative 2. So we can plug that negative 2 in for P and get our final answer of y squared equals negative 8x. If you left it at y minus 0 squared and x minus 0, that's fine. It's true. You don't need the zeros, though. But I wouldn't mark you wrong for having written them. For number 6, we have a vertex at 0, 0, and a directrix at y equals -3. So we need to know how to graph that line. The line y equals -3, is it a horizontal line or a vertical line?
Vertical.
Well, we are like split down the middle.
Horizontal.
Y equals -3 is the line where y is always -3. So that means it doesn't matter what x is. We need a height of -3. So is it horizontal or vertical?
Horizontal.
I need a height of -3 always. A y equals line crosses the y-axis. Y equals -3 means that it always has a height of -3. So that line is a horizontal line, which means that our parabola must open up like this. So the parabola is vertical, but the line is horizontal. Our equation then from the chart is going to be x minus h squared equals 4p y minus k for our vertical facing parabola. What are h and k? Zeros in this question. The vertex is 0, 0. So those are both 0. P is the distance from vertex to focus, but we weren't given the focus. How do I know where the focus is going to be? The directrix. So the focus should be 3 up above, so that means P is going to be +3. Upward is a positive direction. So that means our equation is x squared equals 12y. Questions on parabolas? I don't usually bother plotting circles because I don't have a choice to make in the equation. There's only one circle equation. So since I don't have to decide if it's horizontal or vertical, I don't usually plot them. So what are h and k here? Zeros. H and k are the center of a circle. And this one is centered at 0. What is r? 5. R is the radius. So then our final equation is x squared plus y squared equals 25. If you left the zeros in there, that's fine. If it's x minus 0 squared and y minus 0 squared. Number 8 is a circle again. So we'll start with our base equation from the chart. What are h and k in this problem? They're both 2. Remember, it goes alphabetical, so that h refers to the x and k refers to the y. They happen to be the same in this problem, so it doesn't make a difference. But make sure that your h is with x and your k with y. And what is r? 3. So when we plug those values in their spots, then we get x minus 2 squared plus y minus 2 squared equals 9. Do not square out those two groups. This is standard form, and that's how we want it left. We don't want anything distributed out. Questions on circles? For our ellipse, we have our center at 0, 0, a vertex over 0 up 8, means we should also have one matching that, and a covertex over 6 out 0, and we should have one matching that on the other side to get our ellipse. So technically this is vertical facing because it is taller than wider, but with an ellipse it doesn't actually make that much of a difference because x always comes first, and then it's just what we call the bottom in terms of being a's or b's. But I just don't usually even write anything down there. yet. What are h and k going to be? 0, 0 is our center. The only time that h and k are the vertex is for a parabola, because a parabola doesn't have a center. Everything else has a center, so then h and k should define the center. Now I have to figure out what goes under the x and under the y. In our picture, from the center to the edge, going sideways, is 6 units. What do I do with that information?
Put it on the phone.
Square it and put it under which letter? The x. Since it's a sideways, x is sideways, so under the x is going to go a 36. Likewise then, from center up to edge is 8. Square it, and it's in a y direction, up and down, so that's going to be 64. Questions? The last one's a hyperbola, centered at 0, 0, foci out 4, and vertices out 2. Should open up around those foci. So that means this is a horizontal facing one. So in the chart for a horizontal facing hyperbola, x comes first. What are h and k going to be? The center, so in this question, 0, 0. In our graph, or our sketch, from center to vertex is 2. What do I do with that information? Square it and put it under the x. It's sideways, so x is sideways. So since it's a left or right measurement, square it and put it under the x. We don't have any information about a vertical measurement. We weren't given any measurements up or down, so we don't have any information directly to put under the y, but there's a number there. So what we need to do then is use the other equation in the chart listed for hyperbolas, which is c squared equals a squared plus b squared. C is the distance from center to focus. C is the distance from center to focus. Lots of C's in that phrase. C, center, focus. So what is C in this question? 4. From our center out to our focus is 4. So C is 4. A is the distance from center to vertex. Or you can think of a squared as being the number we already know. A squared and b squared are supposed to be our denominators. So I know one of the denominators is 4, and I need to solve for the other denominator. Okay. So C is center to focus. Then a squared and b squared are the two denominators. The other one we have to. So 4 squared is 16. So we get 12 for b squared, and that's our other denominator. So C is center to focus. A squared and b squared are the denominators. Questions? You need to determine is it. So which type of conic do we have in number 11? A circle. Where's the center of this circle? 0, 0. How can we tell? There's nothing added or subtracted with the x's and the y's. And what is the radius of this circle? 6. The square root of what it's equal to is our radius. So you go 6 in each direction and connect as round as possible. What is number 12? A parabola. How can I tell? Only one variable is squared. Now from the chart, and always be careful with parabolas because they, to a lot of students, feel a little bit backwards. Is this going to be a horizontal or a vertical parabola? A horizontal. When y is squared, it's a horizontal parabola. Where's the vertex? 0, 0. Vertex is h and k. There's nothing added or subtracted to the x's and y's. So our vertex is 0. The other thing that parabola is the focus and directrix. In the standard equation, our coefficient is supposed to be equal to 4p. So in this question, if that coefficient is 8, that means p must be 2. And if this is a horizontal parabola, then I'm going to go a distance of positive 2 away to make a focus to the right, and negative 2 away to make a directrix to the left. And sketch in the parabola. The p-value of 2, it should be a little bit more wide, but I'm not going to be picky about width. But you do need to have the focus and the directrix placed. Questions on parabolas? What type of conic is number 13? And how can we tell? How can we tell? The subtraction. So the key here is the subtraction. So it has to be a hyperbola, but it doesn't quite look like the equation because it's not in standard form. For hyperbola, we need it to be equal to 1. So our first step is to divide everything by 25 to make this standard form. But that subtraction means that this must be a hyperbola. Where's the center of the hyperbola going to be?
0,
0,
0.
0. We can tell that because there's no subtractions with the x's or y's or additions. Under the x squared is now a 25. What do I do with that information?
5.
Square root it and get 5. And which way do I take that measurement? Left and right, because x is a left and right thing. Under the y, it's also a 25. So square root that is 5. Take that measurement up and down, because y is a vertical thing. What do I do with those 4 points? Make a box around them. And draw on the diagonals. And then I need to draw in the 2 branches. How do I know whether they go in the top and bottom or the left and the right sections?
X is the minus 5. And that's the X is first.
Whatever letter comes. So since x is first, it's going to be horizontal. So I want to put it in the left and the right sections. What do you notice about number 14? It is exactly the same equation, except the x and the y are switched. So all the measurements are going to be the same. It's just going to be in the top and bottom sections instead. So we don't really have to do all the work that we did beforehand in graphing. We can just copy it over, but put it in the opposite sections. Because the y comes first on this one, that means it must be vertical. But all of the measurements are the same. Questions on hyperbolas? Problems. What kind of a conic is number 15? How can we tell? It's added, but so is a circle.
They're not the same.
They're not the same. If it's a circle is kind of a special case of an ellipse where it's just as wide as it is tall. In particular, we have different coefficient values, which means that it's going to be wider or taller in one direction, making it an ellipse instead of a circle. It's not in standard form, though, so like the previous one, we need to divide through by the 144. Giving us x squared over 16 plus y squared over 9 equals 1. Where is it centered? 0, 0. There's nothing added or subtracted from the x and the y. Under the x squared is a 16. What do I do with that? 4 left and right. Take the square root, and x is a left and right measurement. And under the y is a 9. So up and down 3. And since we're looking for an ellipse here, we just connect around. Last one, what kind of a conic is 16? An ellipse as well. Where's the center? Negative 1, 0. Opposites of what's added or subtracted. Because the equations are x minus h and y minus k. So h and k are the opposites of what's added or subtracted. So negative 1, 0 is our center. Under the x is a 9. Square root it is 3. And x tells us about sideways movement. We go sideways 3. Under the y is a 1. Square root it is 1. And y tells us about vertical movement. Questions?